A good day to everyone who's watching. My name is Kasule Moses to take you through in our lesson 7 of matrices. We are going to talk about the identity matrix. So an identity matrix is a square matrix having 1 in the leading diagonal, 0 in the minor diagonal. Most cases it is denoted as capital I to mean our identity matrix. So if it is a 2 by 2 identity matrix, so it is having a 0, 0, 1. So this one here is what we call the leading or major diagonal, and then that one I've dotted is what we call the minor diagonal. So takes us back here, 1 in the leading diagonal, 0 in the minor diagonal. A 2 by 2 looks like that. So if it is a 3 by 3, that identity matrix having an order of 3 by 3, so it would have been like 1, 0, 0, 0, 1, 0, 0, 0, 1. So it would have been like that. In that diagonal we are having a 1, then zeros anywhere. Then we have some things to note when we are talking about an identity matrix. The first is that when you multiply an identity matrix times itself, you get itself. Then if you have a matrix A times that identity matrix, it is the same as identity matrix times matrix A, which is again matrix A. An example. Can have an example. Suppose for note 1, our identity matrix, a 2 by 2 identity matrix. I'm having that. So I times I, substituting, this is 1, 0, 0, 1. This is 1, 0, 0, 1. Row by column, that is 1 and a 0. When you add, you get a 1. That is 0 and 0, you get 0. That is 0 and 0, you get 0. That is 0 and 1, you get a 1. So we have multiplied identity matrix times the identity matrix. We are getting again the same identity matrix. Suppose I'm having my matrix A for note 2. I'm having my matrix A as 2, 3, 1, 4. Then I multiply the identity matrix times the A. So that is 1, 0, 0, 1 times, this is 2, 3, 1, 4. Row by column very fast. Row by column, that is a 2 plus 0. This one is a 0 plus a 1. This one is a 3 plus a 0. This one is a 0 plus a 4. So I've multiplied the identity matrix times A. I get the value that I get, or the matrix that I get, is the original matrix A. Now suppose I multiply A times that identity matrix, that is 2, 3, 1, 4. Then times 1, 0, 0, 1 is equivalent to, row by column very fast, 2 plus 0, then 0 plus a 3, then that is 1 plus a 0, which is 1, 0 plus 4, which is 4. Again, even here, I'm getting the original matrix, which is A. So when I multiply that times that is the same as, which is the same as the original matrix. So I'm having that if A is equal to 1, 1, xy, and a squared is equal to I, where I is an identity matrix, find the values of x and y. So the lead I have is a squared is equivalent to the identity matrix. So we saw that in the previous lesson we are having that when they talk about a squared, then I substitute 1 1 xy 1 1 xy is equivalent to the identity matrix 1 0 0 1. Then I begin on the left hand side, I begin row by column very fast. This plus that. Then row by column 1 plus y. Then row by column y plus xy. Then row by that column x plus y squared is equivalent to 1 0 0 1. Then I'm having two matrices and they are equal to each other, and we said the corresponding elements should be the same. So I'm having my 1 plus x is equivalent to the 1. This one here is equivalent to that. So I take the 1 the other side. X is equivalent to 1 minus 1. I get the x value as 0. Then I'm having this is equivalent to that. 1 plus y is equivalent to 0. Y is equivalent to, becomes a negative 0 minus 1, which is negative 1. Therefore, the x value is 0 and the y is negative 1. So example 2 is involving so many things now. Given matrix A, which is that, matrix B is that, find matrix M such that 3M minus 2I is equivalent to 2A minus the B. So it involves the identity matrix, multiplication by a scalar, addition, subtraction, all that is involved in example 2. So the lead, I begin with the lead, 3M minus 2I is equivalent to 2A minus matrix B. So I substitute, I don't know matrix M, then 2 times the identity matrix 1 0 0 1 is equivalent to 2, substituting 4.5 1 0 7 minus matrix B, which is 2 negative 1 3 1. I said in mathematics there are so many ways of killing a rat. Someone can first let this matrix to be A, B, C and then D. So as you get the values of A, B, C at the same time, and then you substitute to get your matrix M. So when I continue multiplying there, that is a 2 0 0 2. On the other side, multiplying there, that is a 9 0 2 14. Then minus a 2 negative 1 3 1, and then 3M minus the 2 0 0 2 is equivalent to, I subtract the other side of the equation, that is the right hand side. So this minus that is a 7. That one there, 2 minus minus 1 gives me a 3. Then this one gives me a negative 3. Then this one gives me a 13. Now I can take this matrix here, the other side of the equation. I'm still having my 3M is equivalent now to 7 3 negative 3 13, then plus my 2 0 0 2. So 3M is equivalent to, now we add, when we add, that's a 9. When I add, that is a 3. When I add corresponding elements, when I add, that is a 15. Now, since this is a scalar, the 3 is a scalar, I'm allowed to divide it both sides of the equation. So 3 divided by 3 is equivalent to, when I divide it the other side, it is going to become a third. Because the scalar here is a 1, so I've divided the scalars on the matrices like that. So I'm having a third to multiply whatever is inside the bracket, and there I get a 3, there a 1, -1, and then a 5 as my matrix M. So try out those numbers and then you'll be giving me a feedback.